Okay, indirect measurement, you want to set them up as proportions. So I'm going to show you how to do that from a diagram and from just a regular old word problem. Kevin wants to measure the height of a tree. He sights the top of the tree using a mirror that is lying flat on the ground. The mirror is 35 feet from the tree, and Kevin is standing 12.4 feet, we're talking about feet here, from the mirror shown in the figure. His eyes are 5 feet above the ground. How tall is the tree? Round your answer to the nearest foot. The figure is not drawn to scale. Okay, so I want you to notice here for each one of these is that we are really, in their diagram, we are given two different right triangles. So I have outlined those so that you can see that. So we have a height and we have a length of each triangle. So set these up like fractions, just like this. Now the height of this tree, we don't know, I'll call it x. So once you do that, look, you have a fraction here is 5 over 12.4, and the fraction over here is x over 35. Okay, so you're going to take the numbers that are diagonally across from each other and you're going to multiply those, and then you're going to divide by the number that's not circled. So when you do that, you get 14.1, but it said round to the nearest foot, so I'm going to call that 14 feet. And that's how you do that. John wants to measure the width of a river. He marks off two right angles as shown in the figure. The base of the larger triangle has a length of 64 meters and the base of the smaller triangle has a length of 29 meters. The height of the smaller triangle is 17.6 meters. How wide is the river? Round your answer to the nearest meter. The figure is not drawn to scale. Okay, on this one, you've got to be really careful because you have two right triangles, but they're not facing the same direction. So I'm actually going to redraw these so that I can see them better. I'm just going to draw them side by side, making them face the same direction. So the first triangle is x, because the question mark is there, and 64. The second triangle, they tell you the base of the second is 29. That means the height is 17.6. So they have literally flipped this thing on its side. Now, look, you've got your fractions. So x over 64 equals 17.6 over 29. I'm going to take the numbers that are diagonally across from each other that I know what they are, 17.6, and you multiply those times 64, and then divide by the number that's not circled. So divided by 29. When you do all those calculations, you get 38.8. But it's said to round to the nearest foot. Okay, because the number after the decimal is larger than a 5, you have to add 1 to the number in front of it. So it's not going to be 38, because 38.8 is actually closer to 39 when you round it. So we're talking about 39 meters here as the answer. Now the next one, they did not draw a diagram out for us. They just gave us a word problem. So I actually write off to the side what they're talking about. So a pole, so we're talking about the height of a pole that is 2.6 meters tall casts a shadow. So we've got two things here. We've got a pole and we've got a shadow. So I'm going to set up my proportion like that. So the pole is 2.6. The shadow is 1.18. And then the next sentence says, the same time the nearby building casts a shadow that is, so they're giving you the shadow, which is on the bottom of our fraction, 47.25 meters long. How tall is the building? The pole is actually the tallness, and the shadow is the length. Okay, so how tall is the building? So that's the height they're asking for. So I'm going to do 2.6 times 47.25, and then divide by the number that's not circled, 1.18. And you get 104.1. But they say the nearest meter, so that rounds to 104 meters. Because 104.1 is closer to 104 than it is to 105.